Hi, we are Cambridge Teeter, Ben Friedrichs, Jake Post, Sal Gonzalez, and R. Jung, and our project is Totally Clueless. So, what we're going to cover today is the background of our database, a description of the project, some more detail about our ERD, some of the code involved, some of the views that we were able to create, and some reports on our data. So I wanted to start by giving a little inspiration and sharing a video about what inspired this project. This is from the movie Clueless, if any of you are familiar. We'll get it started.
But seriously, I actually have a way normal life for a teenage girl. I mean, I get up, I brush my teeth, and I pick out my school clothes.
Okay, so that was pretty formative for me as a child, and I don't know about any of you, but what we were hoping to address with our database based on that outfit was the issue of we just have so many cool articles of clothing, but we can't always decide what to wear. So we thought, what if we had a system to make outfits out of articles of clothing, remember the last time we wore them, and track the outfit's reception? Enter the Clueless database. We spent a lot of time analyzing and reviewing our inspiration, and we did identify some key connections that were missing in the original database software that was presented in the movie Clueless. So I'll share that here.
On top of everything else, I was going to take the driving test. So I had to find my most responsible looking ensemble. Where's my white collarless shirt from Fred Siegel? Lucy, where's my shirt?
Probably at the cleaner.
Oh, but today's the driving test. It's my most capable looking outfit.
So
On top of
after
everything else, I was going to take the
Right. We thought that we could do better. So, due to the limitations of the software presented in Clueless, we decided that we would create a system that kept track of locations and would allow for searching those locations for specific items of clothing, looking at locations such as various closets within the home, car, whether things are in the laundry, so that we wouldn't be caught not having our most tasteful looking outfit. We also wanted to consider aspects that would contribute to being able to match items of clothing together in an outfit, such as color, material, and brand. And we wanted to consider the wearability of the outfit or individual items of clothing. So whether it was appropriate for the weather, which is obviously a pretty big deal here in Seattle, the formality of the occasion. So if we are going somewhere casual, we're going to the gym, or we are going to, like something more formal, like a job interview, we wanted that to be attached to specific items of clothing as well as full outfits. We created a way to review the reviews we got from outfits, including compliments, how comfortable the outfit was, the overall style, and then also to be able to track repeated outfits.
All right, so here we have our ERD that we used for the project. Our ERD shows our relationship between the most fundamental entities that make up articles of clothing. These are things like material and color. We've named these our descriptor entities. The individual articles of clothing themselves, things like jewelry or jackets. These are called our clothing entities. and the outfits that these articles create and people's reviews of these outfits. And we've named these our outfit entities. As you can see, most of our relationships are non-identifying. We do have an exception, which are the direct identifying relationships between total outfit and review, total outfit and outfit accessories, and total outfit and outfit type, which can all be seen at the top of our ERD. This kind of shows that the most central and most direct relationships in our project are all based around the total outfit entity. That makes sense because the core of our database is creating outfits and seeing how other people feel about them. So those descriptor entities that we talked about earlier, the smallest, most building block entities, are made up of brand, formality, clothing location, color, and material. These are things that describe each clothing item. Additionally, some of these descriptors have multiple attributes making them up. As you can see, color is made up of primary color, but also potentially secondary and tertiary colors. In addition, formality has both formality and a vibe, a kind of harder to determine je ne sais quoi kind of attribute. The clothing entities are the clothes, and each clothing item has its own entity. The clothing items are, as you can see, handbags, jackets, jewelry, headwear, tops, bottoms, one pieces, and shoes. The clothing entities go on to make up outfit types and outfit accessories, which themselves are going to be part of total outfit. Here we have outfit entities. Total outfit, that kind of central entity in our database, is made up of outfit type and outfit accessories. It also has weather, review, and date last worn as attributes. Some of the business rules that we were applying for this are that due to thrifting, not all items have identifiable brands. Clothing items with unknown brands are considered to have no brand. This is represented by the record null brand. Items with a known brand can only have one brand listed, and an outfit does not require each article of clothing to be present. However, there is a large asterisk attached to this last point. This is one of the biggest struggles that we had in the project. Not all clothing articles are necessary to make up an outfit. However, our outfits do need to reach a certain baseline of acceptability. To meet this baseline, we decided that each outfit needs either a top and bottom, a single one piece, a bottom and a one piece, or a top and a one piece. But we were having difficulty enforcing this. The solution that we came up with was creating the associative entity outfit type, which is made up of tops, bottoms, and one pieces. The articles not being used could be accepted from each outfit, with a record stating it wasn't present, such as null top under the top entity. The created entity, outfit type, gives us our base acceptable outfit. By then making outfit type, accessories, date last worn, and weather as attributes of total outfit, we are able to retrieve uniquely identifying total outfit IDs that adhere to our sartorial business rules.
So the code we used to implement our ERD, you can see two examples here. On the left, we have one example of our entity one pieces. And you can see here that it references each of those descriptor tables, brand, formality, clothing location, color, and material. On the right, we have our an example of the review table, which has each outfit's review. This table is an identifying relationship with the table total outfit, because you cannot have a review without an associated outfit. And here we used a composite key to reflect the identifying relationship you can see on the bottom there. Here is an example of one of the views we created. we wanted to be able to see what outfits were worn and when to avoid repeating outfits. So we created a view that lets you see the last time an outfit was worn. On the top, you can see our select statement, which combines a computed column with a bunch of joins that show us the type of each clothing item per outfit. You can see the resulting view on the bottom. And for example, we have outfit number 3, which is last worn 219 days ago. It was a tank top with shorts and hiking boots, beanie, a rain jacket, and a backpack. And so we can see, okay, we wore this outfit 219 days ago. It's okay to wear it again. And it also allows us to know what outfits need to be laundered or not.
So another view that we implemented is called purple and gold tops. So this view is intended for anybody who's looking to pick out an outfit with a top that shows a bit of school spirit. So you can see here, we selected the color ID, and then the color ID as well reflects the primary color, secondary color, and territory color. So for instance, something with the color ID 7 is purple, or something with color ID 18 is black, purple, and brown. And then we also pulled top ID, type, and location ID. So for instance, top ID 7002 is a purple sweater, and you can find it in the location ID 8. And yeah. So here are two pie charts showcasing the different types of clothing and accessories that we have. So for tops, bottoms, one pieces, and jackets, you can see that the majority of types of clothing are tops at 41%, and then followed by bottoms and one pieces, which are tied, and then jackets by 19%. So there are 22 tops, 11 bottoms, 11 one pieces, and 10 jackets. And then for the accessories, it's pretty even across the board for shoes, headwear, handbag, and jewelry. So that's 10 shoes, 11 headwear, 9 handbags, and 10 jewelry. And then here we have another visualization that shows us the different formality of the tops, bottoms, and one pieces that we have in our database. So out of all tops, bottoms, and one pieces, you can see that the majority of our clothes that we have are mostly casual, and then followed by professional and formal. So what this means to us is that we might have trouble getting some variety when it comes to formal or professional events, and that it might be time to go shopping.
Here are two more visualizations. The first one shows our reviews of our total outfits. As you can see, 50% are positive, but there's a sizable amount, like 40% being negative views and the rest being neutral. And this shows that we might have to up our fashion game. Not A lot of our outfits are not getting great reviews. The second visualization shows the average temperature we wear our jackets in. As you can see, we mostly wear our jackets in the 60 to 70 Fahrenheit range. However, we also wear the heavier jackets in colder temperatures. And this can help us decide which jackets to go wear during which weather, or depending on how cold or warm the day will be. We would also like to point out some highlights and some challenges we underwent through this process. So what was implementing unique identifiers, we managed to succeed in our goal to go I guess to mark all our clothing articles and be able to go call them up when needed. We also implemented constraints, which help control data integrity as well as determine what type of data could be entered specifically for the jewelry and top entities. We also added the locations entity, which was not something that the original Clueless movie had, and this will allow us to go make sure we don't lose any of our articles or that we can go find them whenever we need them. Our days since last worn view is also some especially useful because it shows us stuff of like when if we like wore an outfit way too long ago, it might be old enough for us to go retire it, or if we need to go wash an outfit or um, etc. We also created a controlled vocabulary enforced by constraint checks. This is applied to like the attribute types, and especially for the jewelry and tops entities again. One of the challenges we came across and we mentioned before was that we need to enforce the business rule about our baseline outfit of like wearing tops and a bottom or just a one piece, etc. And we couldn't find a way to create a subtype structure, and so we created an associative identity entity instead, which was the outfit type entity. Any questions, comments, or concerns?
So I have a question, and it might be a little bit outside of the scope. I'm not sure. If anything, I think it might relate more to like business rules. But I was curious, I know at least within my wardrobe, I have like a pair of pants that could fit either like more of a casual tone or a more professional tone, um, depending on like the shirt it's with or kind of the what else I'm wearing with it. And so did you kind of discuss that at all or kind of think through um, talking about how like some items of clothing can be like very versatile in how they're worn?
Yeah, I can take that one. Yeah, we did. That was something that came up as we were kind of going through and creating the entities. So we made sure that there was a formality ID associated with each outfit as a total as well. And we didn't require any like constraints that individual clothing items be pulled from a specific formality in order to go into an outfit that has a total formality of, like a formal, professional, whatever. That issue came up, I think, a lot, especially with like jewelry, where it's like, okay, you can wear, this kind of ring to so many different types of situations. So, um, yeah, we did. And so we decided to have like it applied to clothing types as individual pieces and then as the overall total outfit type too, in the
Okay.
review section specifically. Thank you, though. That's a good question.
Yeah, thank you.
I think Aiden has a question.
Hi. So I actually had a question about the vibe category. How did you guys create that? Was that like good vibe, bad vibe, or was it a range of vibes?
I think we did varchar, right? I think vibe isn't exactly measured. I think we just kind of vibed it.
Yeah, I think
Let's say
it's
vibes are not Boolean.
Yeah.
That was more kind of like a subcategory. So, like you have casual, but what you're gonna wear to the gym as a casual outfit is different than what you would wear for like night out with friends, casual if you're going to like a dive bar, or if you're just like going to walk around a museum or something like that or class. So that was kind of how we conceived of the vibe portion.
Wonderful. Thank you guys.
I think the next one is Allie.
Yeah, I guess I was wondering about like who the user is that you see like interacting with this database. Would it be just like an individual person? Is it like are you guys like essentially the people who this would be? Would it be like, you know, something that multiple people would be able to use? I guess just yeah, I'm curious about what you're thinking there. Is there
It's Cambridge. The user is for sure
It's just
Cambridge.
Cambridge.
Cambridge served as the formative model for this. I think the general locations and style of outfits and kind of the basis of the controlled vocabulary for a lot of the entities came from our real life use case of Cambridge.
I think presumably we could also apply this to a different individual, but we'd have to like insert data from their own closet into the database. So I guess it would be like the database is aimed towards individuals, but in this case specifically, it's aimed towards Cambridge.
And also to add on that, I think something where this project could go into the future is kind of like you brought up Ali, which is to make the audience more wider and take into account different types of clothing that people around the world wear, which is something that we didn't really keep in mind during this, but would be a great idea for taking this project in the future.
amazing. Thank you guys so much.